In this podcast, we're going to talk about Dalton's law. Dalton's law deals with partial pressures of gases. So basically, if you put a bunch of gases, a mixture of gases, into a container together, they're each going to exert a specific pressure. If you take each of their individual pressures or their partial pressures and add them up, that can give us the total pressure of the container. And that's exactly what Dalton's law says. So P total is equal to P1 plus P2 plus P3, etc., so on and so forth. All right, this leads us into the idea of the mole fraction. Basically, the mole fraction is the portion of the substance that is that particular element. So you can take the moles of the substance over the total moles, and that'll give you the mole fraction, which is this funny little symbol. Or you can also do this for pressures. Now, my little P total, he got scooted over for some reason, but the pressure of one of the gases over the total pressure of the system gives you just the percentage, if you will, of the total that is just that one particular gas. Very useful at times in chemistry. Alright, so here's an example. The partial pressure of nitrogen in air is 592 torr. The air pressure is 752 torr. What is the mole fraction of nitrogen? So we know that 592 is just nitrogen, and then we know the total air pressure is 752. So we divide and we get the mole fraction of nitrogen as 0.787. Okay, now if I were to ask you, another question, such as, if that's the partial, what is the partial pressure of nitrogen in this container that holds the air, that the air is compressed to 5.25 atmospheres. So this is the pressure of the whole system. Now if we multiply by the mole fraction that we just found, that'll give us just the pressure of the nitrogen, or the partial pressure of nitrogen in the system, which is 4.13 atmospheres. Okay, so you can use the mole fraction to help you get to the partial pressure. Alright, this is a challenging problem. I'm actually going to back it out of full screen because I'm going to need a little bit more room to write this one. Alright, so you have three separate flasks here. They are all connected, but they are kept from mixing together because of these stopcocks here that are keeping the gases from mixing. The first container is 4 liters, has a pressure of 2.70 atmospheres, and holds CH4. Then we have the second one that has nitrogen. This is the volume, and this is the pressure of the nitrogen. And then this one has oxygen. This is the volume, and this is the pressure. It wants us to determine the partial pressure of each gas and the total pressure when we were to open these valves right here and allow these three gases to mix into this one container. So whether you realize this or not, this is a straight up Boyle's law problem with a partial pressure Dalton's law added in. So we know that the initial volume of each container is given. So we have 3 separate V1s and we know the pressure of the gas by itself before it mixes for each of these. Alright, and we know that when we open these valves that the new pressure will be 4, not new pressure, the new volume will be 4 plus 1.5 plus 3.5. Okay, which gives us a total of 9. So we know that for all of these instances, our second volume is going to be 9. Now, we need to find the pressure of each gas when we open up the valves. That'll give us basically the partial pressures of each, and then we can use those to find the total pressure. Alright, so we're going to do 3 separate Boyle's Laws problems. So I'm going to separate them so that we can try to keep them all straight. Alright, the first one. Alright, so we've got Boyle's Law is P1 V1 is equal to P2 V2. Alright, P1 is 2.7, V1 is 4, P2 is what we're trying to find, and V2 is 9. Okay, when we work this all out, we find that the second pressure is 1.2 atmospheres. Okay, so that's the partial pressure of CH4. Alright, now we're going to do a P1 V1 P2 V2 problem. Same thing, but we're going to use these second values. So pressure 1 is 4.58. Volume 1 is 1.5. Pressure 2 is what we're trying to find. And volume 2 is 9. Okay, we work all this out and we find that the partial pressure of nitrogen in this case is 0.763. Okay, and then we're going to do our last Boyle's Law problem. So we got P1 is 0.752, V1 is 3.5, looking for P2, and V2 is 9. Work all that out. Partial pressure of oxygen is 0.292. Okay, so here's all our partial pressures, and then if we just add them all up, that gives us the P total, which is 2.3 atmospheres. Okay, so first you have to find the pressure of each gas individually when you give them a different volume. And then after you do that, you add all those up, and that gives you the total pressure of the system. Alright, told you we were going to need a little more room on that one. Alright, vapor pressure. Vapor pressure happens when water evaporates. When water evaporates, the vapor that it gives off has a pressure. We often collect gases over water, so we often have to subtract the vapor pressure of water from the total pressure to find the pressure of the gas that we were collecting. And when you're doing these types of problems, the vapor pressure of water must be given at the specific temperature you're working in. Alright, so here is an example. Shows us how N2O can be produced. I'm going to go back widescreen on this. Alright, so we know that the total pressure is 94 kilopascals, and we know to get out of kilopascals and get into atmospheres, because that's always a great standard unit to work in, we would get, we divide by 101.325, and that would give us, let's see, 0.928. Okay, so that's our P total. And we know that the vapor pressure of water is 21 torrs. Okay, so that's our pressure of H2O. It is 21 torr. And to get out of torr, we divide by 760. So that gives us our vapor pressure of water of 0.028 atmospheres. Now we know that the pressure of the water plus the pressure of the N2O gas gives us our total pressure. So we subtract these two, that gives us just the pressure of the N2O. So that's 0.9 atmospheres. Okay, now we can actually try to answer the question, which is what is the volume? So we know the pressure. We know the temperature. We're going to have to add 273 to that 22 though, and that will give us 295. Okay, and we know that we have 2.6 grams of NH4NO3. So if we take that 2.6 grams, the molar mass of NH4NO3, which is 80.0406. My bad, 0456. All right, that gives us the moles, okay, which is 0.0325. All right, now we have everything we need to plug this big bad boy into the PV equal nRT equation. So you're going to plug in your P, you don't know V, your N, your R, which is 0.08206, and your T, which is 295. And once you do a little math, I'm going to spare you, you find that the volume is 0.87 liters. Okay? All right, and that's it. That's about all you probably ever wanted to know about Dalton's law.